All right, let's begin with quiz 2. This is going to cover your complex numbers and completing the square. So looking at problem 1 through 10, we're going to be dealing with our complex number system. So on number 1, you have a negative under the radical, which you know you can't have. So right off the bat, we're dealing with an imaginary unit. That negative sign will come out as an I. Now deal with the square root of 64. 8 times 8 is 64, so I know the solution will be positive 8i. On number 2, we need to simplify 108. 108 is not a perfect square. Okay, so what we're going to have to do is we're going to have to figure out what we can do to simplify it. So remember, you can list factors or you can do the factor tree. If you list factors, you just have to come up with two numbers you can multiply together to get 108. And then you keep breaking it down until you have an entire list of prime numbers. And that doesn't take very long. So group together your pairs. We have two pairs, or we have two twos, which makes one pair, and two threes, which makes one pair. Then you have this 3 that's going to be an extra number. So don't forget, we've got that negative sign right there, so that's going to come out as an I. But this 2 right here is still on the outside. So 2 times 2 is 4, and the square root of 4 is 2. 3 times 3 is 9, and the square root of 9 is 3. And also, don't forget that negative will come out as an I. The 3 that's on the outside is going to stay behind. 2 times 2 is 4, and 4 times 3 is 12, giving me 12i. So 12i square roots of 3 is my simplified expression. On number 3, you're dealing with a monomial times a monomial. So multiply negative 5 times negative 3, which is a positive 15. Then you have I times I, which is I squared. Well, one thing that we know is that I squared is actually equal to negative 1. So I can replace I squared with negative 1, and I end up with negative 15 as my solution. On number 4, we have I square roots of 7 squared. That means I'm multiplying I square roots of 7 times I square roots of 7. I times I is I squared. The square root of 7 times the square root of 7 is just going to give you the radicand, which is 7. We know that I squared is equal to negative 1, so we end up with negative 7 as our final answer. On number 5, we're adding complex numbers, so remember to add the real numbers first. 8 plus negative 6 is positive 2. Then add the imaginary units. 3 plus negative 12 is negative 9i. And that's our simplified expression. On number 6, we're subtracting, so subtract your real numbers. 5 minus 1 is 4. Negative 9 minus 4 is negative 13i. On number 7, we have a binomial times a binomial. So let's use FOIL to simplify this expression. So first we have 9 times 4, which is 36. 9 times negative 2i is negative 18i. 5i times 4 is positive 20i. And then 5 times negative 2 is negative 10. I times I is I squared. So as we simplify this, we can combine like terms in the middle. Negative 18 plus 20 is positive 2. But I know I squared is equal to negative 1. So I have negative 10 and negative 1, which is a positive 10. Take those two real numbers and add them together to get 46 plus 2i. On number 8, we're squaring a binomial, so let's write that out. And we'll FOIL this as well. So my first terms will be negative 1 times negative 1, which is positive 1. Negative 1 times negative 3 is positive 3i. Negative 3 times negative 1 is positive 3i. Negative 3 times negative 3 is positive 9. I times I is I squared. Anytime you multiply a binomial times itself, your outer and your inner terms are going to be exactly the same. So 3i and 3i is 6i. Now replace I squared with -1 and work them out. 1 minus 9 is -8. Okay, on number 9, we are simplifying this fraction by getting I out of the denominator. Since there's no addition or subtraction, we can simply multiply by I over I, and that'll get rid of I in the denominator. So we'll distribute to the numerator, and we'll have 20 times I, and 8I times I is 8I squared. On the bottom, we have 4I times I, which is 4I squared. Now I can take both of my I squares, and I can replace those with -1. And so that'll give me -8 right here over -4. Now I can simplify this in both directions. So I have 20I divided by -4, which is -5I, and -8 divided by -4 is 2. Put this in standard form by putting the real number in the front and the I in the back, and we get 2 minus 5I. Number 10, that's a whole different story because you have a subtraction problem in the denominator. So to simplify this and get I out of the denominator, you have to multiply by a conjugate. Since you have subtraction, your conjugate will be addition. So you're going to have to FOIL the numerator and the denominator. So let's do the numerator first. We'll have -4 minus 4I over 10 plus 2I. So first will be -40, outer -4 times 2, inner -4 times 10, and last will be -4 times 2. Okay, let's add these two together. And then -8, we will replace I squared with -1. And then combine your real numbers. And we get -32 minus 48I. In the denominator, let's go ahead and FOIL that out. Let me find a good spot. We have 10 minus 2I times 10 plus 2I. So 10 times 10 is 100. 10 times 2 is 20I. -2 times 10 is -20I. -2I and 2I is -4I squared. These two are opposites, so they cancel out. So I have 100 minus 4 times I squared, which is -1. So 100 minus 4 times -1 is 100 plus 4, which is 104. So if you look at this, all of these are divisible by 8. Let's see if they'll be divisible by anything else. So let's try 8 first. 8 will go into 32 4 times. 8 will go into 48 6 times. And 8 will go into 104 13 times. So we have -4 minus 6I all over 13. Since 4 and 13 and 6 and 13 won't reduce, that gives us our completely simplified answer. So simplifying I to the 49th power, since it's an odd number, what I want to do is I want to take one I away and make an even number. That way I can change it to I squared. So 2 will go into 48 24 times. Okay, so I now have I squared raised to the 24th power. The reason I did that is because I know that I squared is equal to -1, and now I can raise -1 to the 24th power. If you have 24 negatives, you're going to have a positive. So -1 to the 24th power is 1, and then 1 times I leaves me with I. On number 12, you'll notice we're multiplying conjugates, so that means your outer and your inner terms will cancel out. Your I squared will change to -1, so you'll be left with a real number. So 6 times 6 is 36. 6 times -I is -6I. I times 6 is 6I. And I times -I is -I squared. Negative 6i and positive 6i will cancel out, leaving me with 36 minus I squared. But I know that I squared is negative 1. So that's going to change to 36 plus 1, which is 37.